Two-Way ANOVA. What is Two-Way ANOVA? It is a technique used to determine the effect of two different variables on each other and the final result using Excel. I have a Mac, so I have to download an extra toolkit, but normally this should be built in with Excel. Today's example, we will be determining if the amount of water and fertilizer an orange tree receives affects the yield at the end of the season. To be sure we can use this technique, we must make sure that the populations are approximately normal using the central limit theorem. The two samples do not affect each other, so they are independent. They have the same sample size, and there are no outlying values. Two-Way ANOVA has no hypotheses that we need to prove wrong. No matter the amounts of water it receives has the same effect on the yield. That's our first hypothesis. Second variable would be that no matter how much fertilizer is added, it also does not affect the yield, and that the variables together combined do not have a result that's greater than the sum of its own parts. Normally, we calculate the sum of squares, but since it's a long and arduous process, we'll let Excel do it for us. Here's the data that I plugged in. Data with easy numbers and a sample size closer to 30. Which means that by the CTL, we should be about normal. By using Excel functions, we can determine the p-values and the f-values. For our fictitious data, we would analyze the effect water and fertilizer had on crop yields. In Excel, I had to go to data analysis and click on Two-Way ANOVA. We would plug in our values and basically variables affecting the results, which was variables water and fertilizer affecting crop yield. Sorting through the data, we see that for the first variable, t is very small, smaller than our significance level of 0.05, and that f is larger than the critical f value. This means that we can reject the null and say that the amounts of water every day affect the crop yield. Looking at the p-values, though, for the second variable and the interactions of the two variables together, the values are very large, so they are not significant. Because of that, we fail to reject the null. Therefore, by Two-Way ANOVA, we cannot prove with this method that both treatments together affect the crop yield. And that's all. That's Two-Way ANOVA, and these are my sources. Thank you.